Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. Oh, hold up, my camera got weird. By the way, I'm having some more connection issues. I know I had some issues this weekend, and I thought I looked into that a bit, and I thought I had fixed the problem, but it looks like it's still a bit unstable. So if that ends up becoming a problem, I might just cut the stream short today. So sorry about that, but I'm gonna get this figured out. Yeah, hold up 1 second here. Better. Yeah, darker, better frame rate's better. Okay, yeah, sorry about that. Yeah, so having more connection issues. I hope it doesn't become a problem, but if it does, yeah, I might just cut the stream short. So yeah, sorry about that. Like I said, I will try and get this fixed again, in addition to what I've already done, but we'll see. In the meantime, hi to guys in the chat. Cries, Colin, Evil, Tomco, Dark Second. How's it going, guys? So I'm continuing on, still looking into whatever is causing these Mario Tennis bugs. Was calling them Space Squash bugs, but now they're Mario Tennis bugs. Because I actually think that's where the problem is. Or, yeah. Problem's obviously in the emulator, but that's where we're going to find it, I think. So, started with, yeah, last couple weeks in particular, hacked a bit into the emulator to see if we could find out exactly where these registers are getting clobbered. Yeah, Evil, it's still the graphics glitches. I basically haven't been working on this project at all, like off the streams right now, so wherever we ended off last week is exactly where we still are right now. Yeah, particularly I found two locations where these registers in particular are getting clobbered. This place and this place. And I don't recall exactly which, well, don't have to recall the registers exactly because in this case it's going to be R12. In this case there was this other routine. I don't think I actually copied that routine out. I should do that. I'll start off by doing that actually. So we'll get started with that. Whoops. By the way, another thing, I actually did upload the streams from this weekend to YouTube, but I have yet to publish those. So I'll do that probably after this stream, while I upload this one. I'll do 100 just to see. Also, I don't know if you guys caught this weekend stream where I was working on that Super Nintendo effect. But I ended up contacting the guy who did the original effect and asking him how it worked. And it's actually pretty clever. And so this weekend, I'm totally going to implement that. Basically take what we've already been doing, but then make some tweaks, and then we'll get the actual effect. I actually can't help myself. I'm going to explain it. So basically, it was that Kefren's bars effect where, like, every scan line, you basically hack the scroll registers to display the same line over and over again. That's the same in his. And also, every scan line, you draw a little bit of the graphics as it scans down, so you get these, like, stretching bars the whole way. His also works that way. So particularly, what's different is that instead of actually drawing the pixel data into VRAM every scan line, which you can't do because, as we saw, you can't write into VRAM. Outside of V blank or F blank. What he actually does is he has the tile set up so that every pixel on that first horizontal line is actually shows one palette index. So he uses mode 7 so that he's able to get 8-bit color in a really convenient way because the way that the tiles are laid out they're not in bit planes in Mode 7. They're actually like linear, which I'm pretty sure it does that in order to simplify the accesses when it actually has to read the pixels. But yeah, or read the pixels like out of order. So yeah, so there's no bit plane, so it's easier to just write those pixels so that each one displays one color from the palette. And then he gets the whole width of the screen as all the different colors in the palette. So then what he does is every scan line, rather than drawing in the pixels, he actually draws in the palette colors that correspond to those certain scan lines for the bars. So I thought that was pretty clever. And the reason it's sideways in Mode 7 is just because it was easier to set up the graphics as a column. And I haven't looked into why this was, but it was apparently easier to set them up in a column with shorter code and then just set the scroll registers so that it was sideways. But everything else about the effect is the same. And in fact, when I do it on Sunday, I'm just going to do it normally, but I'll probably still use Mode 7 for the more convenient tiles as well. So I thought that was nice. So yeah, that was pretty cool. It also explained why, when I opened it in the debugger, the colors were just flashing all over the place and nothing else was changing, because it was actually basically color cycling, but sort of as the screen was being drawn rather than between frames. So that was cool. Also, he hangs out on SNESDev now on EFNet, so as a Revenant. So if you guys have any more questions about that, either catch me on Sunday or just go ahead and ask him. Seemed like a friendly guy. Anyway, it was, well, yeah, so right in this routine here, like the first instruction clobbers R15, and I think it was R12 through R18 that were the problem ones in this case. I had that written down somewhere up here. Yeah. So right off the bat, whatever this routine is doing, it clobbers those registers. Now, this looks to be a bit of a bigger function than I would have expected. See if I can find the return. Pretty big function indeed. Okay, usually they're not this long. I don't think I missed it. But yeah, it was super funny that he was doing it with the palette, because I totally had those same HDMA tables writing into the color memory, and it totally worked. And I should have thought to try that. That was pretty close, but nope. Also, it turns out he actually doesn't use HDMA at all, because he ends up bumping up the CPU speed and then waiting for HBlank, because that's less code than doing the interrupts. So I'm also happy that I was right that would have been simpler if we could get it to work, but was just trying the wrong stuff otherwise. Okay, wow, this is a huge function. This has to be the biggest function I've seen in this whole process. Like out of all the ones that I've dug into in these ROMs. Now I'm just impressed. I hope I don't end up having to reverse engineer that whatever this function's doing. Because this would be some work. Really? This is huge. I don't know. I don't know where the end of this is. Hey, Middle Voids. That's easily my favorite little wave emoji thing that I've seen on Twitch. Whatever they're called. I need to hang out on Twitch more. Both streaming and watching. I haven't said this in a while, but I'm still so satisfied that I'm streaming regularly now. Makes it so easy when it's just like a part of my week. Then it's just fun. Wow, really? I just wanted to see where this function ended. There's no way I missed this. And there goes my stream. Ugh. Yeah, so I really don't know what's up with the stream these days, guys. Really sorry about that. That really bugs me. I mean, you guys didn't miss much because I'm still looking for the end of this function. Which I still have not seen. There it is. Yeah, Ferris reads assembler, and his stream dies and stuff. Part 8 in Roman numerals. That's like the longest. From 0 to... Yeah, that is the longest. I don't know why I do that in Roman numerals. I think it's to separate from the episode number, but I just started doing that now as a habit. Anyway, this was where the end of that function was. I'm going to copy all this. And then I'm actually going to search for that register in Sublime to see if I just missed it. Because this was ridiculous. And the funny part is that clobber is like right at the beginning. So it shouldn't need to dig into this too much, but I wanted to see. Nope, that's it. That was correct. Here it pushes it, and then here it pops it, and there it jumps. Wow. Crazy. It's actually kind of nice to have those markers in there. Except this one. Okay. So in both of these cases, it was clobbering these registers. And I'm hoping that if I look at this, that we can find like some common conditional between these two code paths. And hopefully that will make it easier to find what's actually happening here. So for example, there's... Yeah, this doesn't seem to matter. I'm just looking at these addresses to see if we can find... kind of work our way up. Especially if we look at these branches. As most of these are going like in this code. This one jumps over this, for example, but then we get to this one. And this one branches here. So actually, already right there, we can see that if we get here, we're going to do a conditional and either go here, which will eventually hit this code path, or here, which will eventually hit this code path. And it looks like this code path here will actually also hit this one. So that's actually really, really kind of good, I think. And that also means that whatever value we read here probably isn't actually relevant, because by the time we've gotten here, we've already had a problem. Now this one jumps all the way down there, which may or may not be a problem. So we'll have to see. And that's actually right here, which is a really good sign. Because this, I mean, ideally, this is what we see. Is like really early on, is there something here that causes this to break? So what are some other branches we see here? There's this one, which goes all the way down here, and then we basically skipped everything. So could be that one. That was 698. And then 6B4 is the one I was looking at earlier, which was here. And I think the... Wait, where'd that go? Shoot, where'd that go? 6B4. There. Yeah, this was the one that I was looking at those values, which was... Yeah. The values here. Here. Actually, this isn't a conditional. This is jump always. And there was actually no conditional before this, which means this is probably... Where would we get here? Is this anywhere else? Okay, there it is. So maybe this is some kind of loop here. It puts us back up here. That's actually really likely. This put us down at 698, which is down here. And then right away we have a compare and a branch greater than equal to. So this is probably a for loop, because this will branch over this if this is greater than or equal to. So this is like I is less than 12 or something, or 12 is less than I, or whatever this is. Clobberland. Yeah, this is our actual handler. But I think we determined that the stuff that I found here wasn't actually that particularly relevant. And all the clobbers seem to happen in this other function, so that's where we need to be. That's why I lost those registers the other time. I was looking at the top of the handler, but it's actually this function here. What are my other to-dos, by the way? Okay, yes, that's what we're doing now. Yeah, I think this is less priority, actually. We'll see. Where was this? Yeah, that's in memory. That one may be relevant, but particularly we're doing this. This was the one that was the loop. Oh, I know what this is going to be, Daniel Collin. Oh, I did not know it was going to be the Elix demo, though. Dan Collin just put up this pic. I knew it was going to be that sexy, sexy monitor. I had no idea it was also going to be showing a sexy, sexy demo. Oh, and you got one of the ones with the labels as well. Nice. For the SD2 SNES. Oh, that looks great. And I'm not saying that in a cocky way. I mean the monitor. Oh, I'm super jealous of that, man. That looks so good. How is it for playing games, by the way? I bet perfect. Oh, look at these little bars here and everything. Man, that's awesome. And obviously you got the cables. It's perfect. So nice, he says. Oh, that's so cool. Just ran overdrive. If you sent me that picture, that would be a dick move. Oh, that's so cool. Oh, I'm still thinking about that monitor. It just looks so good. I really want one. No worries, man. I'm happy to be distracted by stuff like that. I'm just really jealous. I'm kind of distracted today anyway. Probably noticeable. No reason why, as far as I know. I'm in a good mood, just distracted. Bad moves, less cheer, more work. I'm not sure what you mean by less cheer. My cheerleading career never really took off. Okay. What I need to do is I need to just look at this value. This 22cc, is this one I wrote up here? No, it's 2288. What I'm thinking. So here, loads this address into R10, adds R11 to it, whatever this ends up being, which looks like it's part of that loop, actually, if this is where that for loop was. So what is... Yeah, actually, wait a minute. So it looks like whatever value it's reading here, which will eventually lead to this conditional, is already kind of within this for loop, because it's based on whatever this R11 is. Right, yeah, because this is part of the loop body. So there's a conditional here that looks like we'll jump over everything, but then I think there's a conditional up here, which should skip all this. Yeah, it does. So actually, we should totally check that state first. Let's do that. So what is R4 here? Because that's going to be our globals. 8. Actually, that's probably this guy, isn't it? If it is, then go me for taking notes. And also bad me for not reading those notes. This was the number. So we had... That is the one, isn't it? 2288? Totally is. Wow. This is our top priority here. So let's do that. Go to... I want to do 2200. Which should give us 2288, which is going to be here. And I'm going to copy this out here. Or actually, let's take a few dumps of this. Yeah. During the title screen, of course it does. I need to name these better, but this will be okay. Yeah, so this is during the title screen. Let's also do just write this address. So that's during the title screen, and then we'll get a couple like transitioning away from it as well. Actually, I should totally get it while the stuff is being clobbered to see what that state is. Yeah, I'll do that. So gotta set all this up again. We need this one. We need this one. And we need these, but not yet. And let's add the watch or the labels as well. Oops. Good. Bang. So they're clobbered. So now we want to go here. Oh, I forgot when I do mem, I don't have to go there because it will just go there already. And here we have it at 9. So that may be interesting. Also, it may be this is a multi-byte value. I didn't check. Where's our assembly again? This was load byte here. No, that wasn't our conditional was here. So it actually loads the word here. So and so that's actually a 4-byte value that's there. Here. Interesting. Okay, so let's remove these. Hey, I am Cedric. Yeah, the stream is really unstable. It's been unstable since this weekend, and it's unstable today as well. Again, really sorry about that. I did look into it, but looks like stuff didn't fix it. Yeah, it looks like I'm reconnected now. Sorry about that. Let me take some more of these notes and then I'll talk about it for a sec. Harbor condition. That's a nice way to put that. I just want to get this one more time. Yes, about the stream cuts, I don't know what's going on. I checked my hardware and I haven't ended up making a call to my landlord or ISP yet. I actually get the internet through my my rental agreement, but I'm going to look into the possibility of upgrading because this is pretty ridiculous. It's only been happening in the last week or so. It's happened very seldom before that, but it's been really bad lately. So I'm really sorry about that, guys. I don't know what the deal is, but I'll call about it in the next couple days. It's definitely an internet issue at my place because like my whole computer disconnects. And some other people who have come over recently have had a similar issue. I don't think it's with Twitch because my machine is completely disconnected from the internet when it happens. So I need to look into it more, but yeah, sorry about that. I'm seeing some interesting things here though. I need to do, let me check this during the menu screen a little more. Thanks, Baggers. By the way, I forgot to ask how your stream yesterday went. Oh, I think it's a big deal. I think it's annoying. Not Baggers' stream. But you know. Ah, it changed. Of course you wanted some stuff in the compiler before showing it. Yeah, Danicon, feel free to steal this as like a drop-down thing for your debugger. That'd be really nice. I'm Cedric. No worries. Been watching over YouTube earlier, so could you please go 25% faster? I'll see what I can do. No, but I'm happy to hear that went well, beggars. Happy to hear about that. But I'll talk to you more about that tomorrow, probably. So I'm seeing a few different values for this. Whether or not this is causing the clobber, I'm not entirely sure just because of the range of values I'm seeing. But it is pretty consistent what the value is when the clobber occurs, which is somewhat interesting. Somewhat interesting indeed. Just kind of eyeballing the rest of this too while I'm here. Seeing if anything else looks like it changes a lot. And these are going to be pretty small numbers. If this is a whole word. Let me go back to the title screen and see if we get many changes there as well. Also just sample this randomly to OC. Almost always seeing OC here. So this is actually an outlier even. In fact, even this one ended in OC. Same value there. There's 0501. Which is interesting because we always see 01 and 05 here. But then we see 01 here. Yeah, that's actually a good idea, Daniel Colin. This is to to print that address specifically. I think I'll do that actually. See what kind of patterns it does when it's changing. Another good thing for a debugger there. Not just have watch points, but just print a value whenever it changes. Like to not break, but just print. Should also be a feature for this debugger, but yeah. For now, I can just hack it. I'll do that here. It should be memory, but we'll just do it here. It'll be easier. Might be easier to just do it here. Although, this is all the translation we need. So let's just do it here. Actually, we'll do writes. Don't need to do reads. Yeah, that's all we have at this level. The word thing is going to be specific to the CPU. And we're not, it doesn't seem to be using those high values anyway. So this actually should make sense. Yeah, trace points might be what that's called. That sounds familiar. In the Linux kernel, it seems to just be a generic callback where you could do anything. Here we got 0 there. Probably initializing RAM or something. Because it's right at the beginning. Oh, you know what? I'm watching the wrong address. We want 88. Yeah, should be good. So much just like random stuff we have to collect when the emulator is almost working properly. Here it's just writing these same values over and over again. Interesting. Just want to watch how this changes. None of these values were values we were seeing. Oh, 101? Okay, never mind. We were seeing a 101. So we're probably good here. Yeah, and there's the other ones we saw. 501 and 050D. That's a new one. Or a 105. C01. Interesting. I'm gonna let this go to demo mode. See if we see any new values. It almost looks like that that low byte could be a game state or something. Just because it matches up so much with the actual state of the program here. I mean, it literally could be anything, but seems to have a pretty high correlation with that at least. Just check my notes again. Yeah, it's always 01 something here. In between it was 09 something. I also hear OA something. We seem to always see 05 during the menu screen and always 04 during during this demo screen. I'm going to pause this after it transitions again, actually. I can just force that. See if we get any interesting changes here. Oh, also, this is actually the high byte, and this is the low byte. That was my bad there. Yeah, so this is the one that's changing. And then this is the, yeah, okay. It's the OC here that we see here. Right, and we always see OC here when it's transitioning to and from the menu screen. By the way. And then always 01 when it's at the menu screen. think that's what we're seeing here. So at some point here it switched. Oh, here was 0, 0 even. Goes to here. We're seeing a 1 here again. The menu, we get OC. Interesting that it changes when I do stuff. 03 here in the game. And then 04. Was it only 03 when it was like showing that opening there? Let me get it to the demo mode again and see if that's also the case. 07 here. 01 here. Let's see this transition into demo mode to see if we get 03 when it shows the like setup for the match, and then 04 when it goes into the match. Because it would make sense if those were discrete states. Okay, it went to 05. And then does it go to 04? Oh no, or was it always 05 in this case? I think it might have been. Yeah, it was always 05. Didn't seem to change. Yeah, I'm also thinking that 05 is the demo state. Where do we see? We saw 4 and 3 here, right? C was the menu. So you see 3 when it shows like the, we can call it match details, I guess. Yeah. Just looking at this really quick. This is where it pulls that value. So ands with 8. Which is going to be checking. Wait a minute. It takes the low byte and ends it with 8. Which is somewhat interesting. Because this would have had that set. This would have had that set. This would not have. And then this would not have. And if it's 0, we do this stuff. Otherwise, we're going to jump over all this. However, that's the low byte. And we also did get this value here, which doesn't have that set. So that's interesting. Evil, yeah. There's some other games with some other glitches. But this one is, it appears to be one of the more predictable ones that glitches like this. A couple streams ago, I sat there trying to get the golf game to glitch for like an hour. And that was really finicky. But this one is really consistent. I'm honestly going to check out the code for the and instruction. Because if this were going to read this value, and it with 8, and then jump over this condition, then why did we get this clobbered? Whoops. It was W4. I don't know if this will fix the other ones. Like I have a list of bugs written down in one of the tickets on the repo and also on the README in the repo. And I don't know if they're related, because there's really no way of knowing that until we fix them. So just fixing any of them is helpful. Hopefully they're related, but we really don't know if that's going to be the case. But what I was thinking was that why would this value be like this when we get clobbers? Because that bit wouldn't have been set. Obviously, the answer is that this condition might have fired, and then we wrote to it. So like here. In fact, here it will set the bit here, and then write to it. So that's probably crap that I'm thinking that. But let's look anyway, because it couldn't hurt. What? Do I have match case on or something? Oh no, I have and immediate is what that is, I think. What? Hold on. Been a while since I've had to look at this. Yeah, okay, and underscore I. First of all, I'm actually going to pull up the datasheet and just make sure this is correct first. Let me hit this up. Here. This one. Been a while since I looked at this sheet as well. That's nice. Was this not the right one? Whoops. Okay, so first of all, 101, 101 is our opcode. And we're looking good there. And this corresponds to this. Okay, and then this will... Yeah, same bits. This is format 5. We'll check that as well, which should say here, format 5. And this... So the immediate 16 gets 0 extended. ANDed with the value in reg 1 and set it to the value of reg 2. So this 0 extended, ANDed with the thing in reg 1, and then here we set it with the reg 2 with the result. Also 0 sign flags, and then overflow is cleared. So overflow is cleared, 0 and sign is here. This is interesting. It says sign is always 0. Yeah, that makes sense actually, because this is a 32-bit value in this register, and then if this gets 0 extended, there's no way the sign extend is going to be, no way the sign value is going to be 1. So the one thing I'm thinking is if my immediate 16 here, if this is a U16, then we should be good. If it's an I16, this is wrong. So I'll look at my format 5 macro. So the first half word is read half word from the interconnect, and that's going to be unsigned, I'm sure. Yeah, unsigned 16 there. And then format 5 gets the second half word from there. The immediate 16 is the second half word, which here is going to be U16. So U16 getting U16 getting cast to U32 should be 0 extend. So that's probably correct. And we'll check this as well, but some of these things are probably at this point gonna be correct. This looks correct to me. Yeah, it would be really unexpected, but totally worth checking at this point, because since there are so many of those bugs that just are kind of weird, like they don't seem to point to the same thing that I can recognize, I would not be surprised if it was this kind of error. So, worth checking. Fortunately, that probably wasn't it. So what's interesting here is it checks that bit here. And if it's 0, if it's not set, okay, wait a minute. Checks that bit, and if that is set, then we skip over everything. Which, if we look at our notes here, okay, so we did see one where it was, yeah, that's the low byte. We did see one where this bit was set, so that didn't seem to be relevant. Because it writes it here. So if it wasn't set, then what happens is it basically gets set. But then it puts this value, which is the same thing with a different bit here, and then stores it here. Also, you can see here that it chops off the top part, so it's a 16-bit value after this. But this is with the like 1-0 bit chopped off. And if we look at this, all these values follow that convention at least. Except this one doesn't. But then, hold up. Yeah, because that would make the last bit 1. So wait a minute. Oh no, okay, never mind. Because this one and this one both have those bits in different states, so that doesn't seem to be relevant either. So this doesn't seem to be directly relevant to our state here. Because regardless of this logic, we seem to get, yeah, different values here, clobbering and not clobbering. So this conditional probably doesn't save us. So the next one going in would be this for loop conditional. Wait, do we jump to 9.8? B4. That was there. Sorry, which one was this? Yeah, 698. Maybe this one is worth checking. And this is an 8-bit value. Yeah, I like to try and indent it once we've definitely recognized the loop. I'll do that in this case if I mark which the parts of the loop, then I'll probably do it. But I don't want to do it unless we've done that in case I get it wrong, which I've also done before. I'm going to use the restroom really quick. I'll be right back. And we're back from our commercial break. First thing I want to see is, okay, here we load the value. Here we store the value. In fact, we set it to 5 specifically. Here we read the value. And here we store 0 into the value. In fact, that's actually interesting. So here we take that value, add 1 to it, make sure it's still an 8-bit value, put the value back. So this is incrementing an 8-bit counter here. And then loads it. See, this is the kind of dumb stuff you see this compiler do all the time. Load a value into this register, increment it, make sure it's 8-bit, store it back into where it was, and then load it into the register again. Peephole much? It's gonna be my new catchphrase. And then it compares it to 12. So this is an 8-bit branch greater than or equal to that. Yeah. So this is a 8-bit counter that's counting up to 12, or 0 to 11 inclusive. Which was that, 23902? Yeah. It looked like some text. But the interesting thing here is it sets to 0 right here. So I don't think the conditional for this for loop is going to be the culprit either. Because it sets it to 0 before it actually goes here, I think. Yeah. There's this code path which interestingly skips over the clobbering. Actually. So maybe it's this one. Baggers, might be a daft question, but could this be related to the sound playback? That number was changing perfectly in time with the ball bounce, and the title bounce also in golf would lock up when the ball fell in the hole. That's interesting. That would be really strange. I'm gonna watch this again. See if I can actually hear that correlation. Okay, this is weird. It's definitely related. Here, let me turn this on. That's so weird. Let me switch. Let's just restart it. So I totally didn't see that correlation, that was changing with the sounds. So good catch. Yeah, it totally is there. Wait a minute. Let me grab my Virtual Boy really quick because I want to see if these sounds keep playing through the transition period. This is really weird. All right, so I've got the Virtual Boy with Mario Tennis. There it is. So what I want to do is I want to get to the title screen and then transition to the other screen. I want to see if the sound lingers through that process. Okay, it still does. Although coming back from it seems to sound a little bit different. Let me check. I have other things set up in my side desk. That's a really funny catch. Really good catch, by the way. Because you hear that sound kind of echo when it changes. But coming back sounds a little bit different, actually. Good-do. Makes like 3 tones. Like good-do. Whoops. Okay, so it is actually, the sound is actually slightly different coming back to the menu. Very interesting. Now, whether or not that's related, I'm not entirely sure. But that is very, very interesting. That seems to cut off the sound there, whereas in the emulator it doesn't. So I'm gonna add that to the notes. Sorry, was that the high byte? Let me check this again. Yeah, it's the high byte. Yeah, that's a really good catch. I totally didn't notice that those were correlated. Or wait a minute. No, that's the low byte. Yeah, okay. Very interesting. Let me, here's something I didn't think to try. Let's try this. Whenever it reads that value, let's just mask that out and see if it doesn't glitch. I should have thought to try that actually when looking at these values, but I guess it doesn't make any sense until we've actually seen the values. Okay, why are we getting... Oh yeah, because it's writing. Okay, still glitches. But I mean, that could make sense because whatever condition that it would write to change the value could have done that. So it's probably like a different state that actually causes it to write the values to this register, or to this memory address. That's why we're always getting like 0008 here. So that probably isn't relevant. Although, let's control the writes as well. Just to see. Just to try some stuff. Still breaks. Hey, Drew. Yeah, you're in the chat. So, I have a hard time making the leap that it's related to the sound emulation. Because there's the way that this hardware is normally driven, at least the way I've seen, is not a lot of these states are usually read from the hardware. A lot of it's like written to the hardware, being driven from the hardware or from the CPU to the audio hardware, and not a lot of state is usually read back. So I have a hard time believing that the audio emulation would affect this stuff. A really easy way to check that, actually, is we can just bypass everything that goes to that entire memory range. So I have a really hard time believing that that would affect the game state. However, if it is correlated with the bug, which at least the values that we're seeing in at that location appear to be correlated, then at least we may have some clue in terms of other places we can look for changes and look for patterns. So it could very well be interesting. But yeah, so it's definitely not the audio hardware that's affecting this, which I'm a little bit disappointed about, because I no matter how weird whatever we find, like no matter how weird the solution to this bug ends up being, if we find it, I'm just gonna be so stoked. But yeah, it's not that, I think, unfortunately. But like I said, may help us find other patterns to look for. Wait a minute. Wait one second here. Oh, okay, never mind. I was thinking, why are we only getting one half-word read here when it's reading words? And the reason is because I'm only checking this one address, and the read words are going to be implemented as two read or write half words. So actually, we need to also check this value here, and then we'll see the right half words, which we should see every time, and they should all be 0, because that's what matched. That was what was in memory, at least. Doesn't look like it actually changes. Like the patterns that's written here changes, but the actual numbers don't seem to change. Also interesting. It seems to never play sound. between those two screens, it never plays sound, and the graphics here I don't think are ever corrupted. Which I usually don't test because it's a lot more effort to test the game than it is to like test the demos. Let me see if we hear a sound in the transition into demo mode. Yeah, I could have done that, but I don't think anything else than 0 is going to be drawn in that case. Ooh, whoa. Did this just lock up? What the hell? What just happened? Let me do a git diff here. To make sure that none of my intermediate changes have been affecting this state, other than like printing values. And then I'm going to look into this. Yeah, I'm going to break into the debugger in a second. I just want to check this first. Looks an awfully lot like the thing in golf. It just looks like I have my watch point stuff here. Oh, whoa. Okay, I missed it. Okay, that I did not expect to happen. So it looks like I missed my chance. I just want to make sure here. Yeah, okay. So nothing in here would have changed the behavior. And then I got an unrecognized address here, 0201. Where would that have been in our memory map? Would have been in this range. But it's really weird to have written that value there. Because it shouldn't be writing those. That was very strange. I have not seen that break like that before. And that crashed pretty hard. You know, I'm actually tempted to run golf in here, and when it crashes, I want to let it sit and see what happens. Now, unfortunately, golf is not the most stable game in the world. But it would be really interesting if it broke in a similar manner and then just crashed like this. The other thing that we can see is I want to look at these patterns in this game as well, just to see if they're at all the same. I wouldn't expect them to be, because it's a completely different game, but you never know. Oh, whoops, I needed to go back to the main menu. So these are probably going to be irrelevant for this game. Remember this song, guys? Oh wait, the screen's black. What the hell? Well, I'm just gonna let it sit. don't even remember these parts of the song. Yeah, today's really weird. Music's still playing just fine, though. Let's see if it's doing anything obvious. R1 is this range, which I don't think really points to anything but some video memory. Seems to be looping here. (2016) in R1. Wait a minute, because R1 in this case is here. The hell's it doing checking those values in video memory? Baggers, I bet you one favorite dies at the end of the song. I would love it to do that. Okay, let me mute this for you. Put on some music for me so that sound doesn't drive me nuts. By the way, if I accidentally play music on the stream, please let me know, because I really don't want to get my videos muted or taken down for copyright violations. So please let me know if I make that mistake. But this is weird because there shouldn't be anything here but video memory. Then again, oh, this better not be just something stupid nasty. Oh, never mind. Of course there's stuff there. Let me do this here. I usually don't see these addresses. Like normally it'll load this address into a register and then offset positively from there. It's odd that it loads this and then offsets negatively, but I guess now we've seen that. Minus 2016, which is easy to remember because it was a terrible year. And then 5820. So it's actually checking the display control register. So it actually totally makes sense that it would be stuck in a loop there. But wait, which state is it checking for? And 8? Loading half word, which should not make too much of a difference, I think. Yeah, in fact, that's all I do there. That's funny. That should be correct. Oh no, I see why I did that there. Okay. Yeah, okay. Looks good. This was display control read, wasn't it? Yeah, it was. And That one, right? Yeah, this one's shift left 2. That would have been 8. So it's basically checking which frame buffer it's drawing into. But it's probably not drawing, which is probably why it's locking up here. Or no, this is where it's displaying each of the frame buffers. Sorry, not drawing. So this is probably waiting for it to be, yeah, for it to not be displaying the right frame buffer in this one particular configuration, which is kind of weird because these will go back and forth. So when it's not displaying this specific back buffer, basically, it's a bit odd. I don't think my debugging code has side effects like that. In fact, I don't think any of these registers have had side effects on reads. If I remember correctly. Yeah, no, I've definitely seen systems where that's the case. And also some where just writing a value regardless of the value will do something, but I don't think there are any of those in the Virtual Boy off the top of my head. And the debugging stuff I added anyway doesn't actually affect any of that because it was just in the CPU affecting values that were written to certain registers, so I don't think that makes a difference. The unfortunate part here, though, is that I don't think I have a command to just write out a certain register. Well, actually, I can use the mem command, can't I? So this read it like this. So this is the value it should be reading. Even read the right register, which is that allowed? Oh no, this is a 16-bit register. Never mind. But 5.2. This one. So display is enabled while it's sitting here in this state. Oh, wait a minute. Let me see. If we actually are in. If I let this run a bit and then see if we're actually in the same place. C90. We're here, apparently. Hey, it looks online. They may be related. At least Baggers pointed out a symptom that may be the same between the two. So I pulled up golf to see. But this is interesting because this 5.2 here, this says the display is enabled. But sitting there waiting for this to be the case, it never seems to be. What are these other bits here? Display control sync enable. That would make this makes sense. Yeah, these I don't emulate. It's like memory refresh and stuff, which shouldn't matter. Hold on, I'm having struggles looking at these hex values right now. Here's the binary representation. 4 and 6. Yeah, 4 is that one, and then 6 is here. It's just scan ready. Makes sense. Yeah. Oh, yeah, I've pointed this one out. Yeah, not entirely sure if this is correct. Yeah. That's not the bit it's checking, so. Should be okay there. No, 2. That was a different game that was fixed by enabling that, but we know that's not true. But that bug wasn't affecting golf. Didn't a couple streams ago I sat there trying to get golf to break. It didn't seem to affect it. So at least the startup hardware state I don't think is affected. I don't think it's a problem here. This just like randomly, the screen was just black and it hasn't crashed. It's just sitting here. I'm a little bit concerned that this is giving the same value every time, though, to be honest. Shift left twice. So it's going to be... Oh, wait a minute. Did I just totally read these wrong? I think I did. So these never seem to be... Well, actually, wait a minute, because this is shift left 2, and so these numbers here are going to be these two here. So yeah, so I did read this right. So according to this, the right frame buffer is being displayed, and it's basically waiting for that bit to be set, right? Yeah, it's waiting for this bit to be set, which would have been... Why am I having so much trouble reading this? Okay, this one. It's displaying the left frame buffer, the second left frame buffer, but it's waiting for it to display the first right frame buffer. That's what's happening here. The VB does not have a PRNG. The software often does, but the system itself doesn't. Yeah, this is... I am taking into account Aninus. Oh, I didn't realize you could play with the bits there. That is cool. Or like onto the left of it. Oh, that's nice. Yeah, okay, yeah. So it's waiting for this bit. But yeah, we're only getting these. So what's weird though is that why is the display not... Why does it seem to be stuck in this state? It should have at least transitioned out of that, like here. If the display is enabled, this should have been able to transition out of that state. So something is strange here. Yes, again. Yeah, it's in this state. Where it's displaying the second left frame buffer. Now, as far as I know, this state here, display first frame buffers, this just toggles. Yeah, I just use this to, yeah, offset the frame buffers there. Yeah, it flips on game clock here. Ah, stream dropped again. I'm gonna wait until the stream seems to be back on for you guys, but Lux Online trying to figure out how the bug can have a random element if the system starts a predefined state. It has no source of randomness. One of the sources of randomness is how long it takes us from when the game starts running until when we start like going through menus. So there's a source of randomness there, if that makes sense. Oh, so annoyed by these stream cuts. But I've explained that away enough, so I'm not going to talk about that again. Yeah, rip. I get it. Windows didn't BSOD. The stream's still up, guys. Yeah, okay. Anyway, this swaps on the game state. It's just so weird that it... Okay, something happened with my connection. It looks like it's not reconnecting. So I'm gonna go ahead and shut off the stream. Sorry about this, guys. I'll have this stuff on YouTube as soon as I can, and then I guess we'll continue this next week. And again, I'll look into this whatever's breaking the stream. But yeah. Anyway, see you guys next time.